Aloha and good morning from all of us here at the Hokulani Imaginarium in Kaneohe, Hawaii. Today, we're sitting out on the ocean instead of in Kaneohe as usual, because we're going to be looking closely at the horizon, and we don't want it hidden behind trees and buildings. This month, September, is important for astronomy, not just because it's when you go back to school and start taking your science classes again, but because an important event happens in September, an equinox. The September equinox is one of 4 interesting, predictable astronomical events in every year which have been observed by people all around the globe since prehistoric times. This equinox, together with the March equinox, and the June solstice, and the December solstice, are important because they signal special points in the yearly movement of our sun across our sky. Now, as a reminder, each equinox and solstice usually gets named for the season it is in, but those seasons are different depending if you live in Earth's northern or southern hemisphere. For example, summer in Hawaii is winter in Tahiti, and so Hawaii's fall equinox is Tahiti's spring equinox. Let's break down that word equinox. It's built from the roots in the Latin language, equus and nox. Nox meant night. Equus is the root of our word equal, as in something that measures the same as another. So, equal night. But equal to what? Well, the equinox is often said to be when day and night are the same length of time. There's one more thing we should make sure we understand before we dig into the equinox more. Why are all days not the same length? That is because Earth spins on a tilt as it goes around the sun. During the Hawaiian summer, Earth's north pole is tilted towards the sun, so the hemisphere where we live gets more direct sunlight, and we have more hours of day than night, because we don't rotate through as much darkness in 24 hours. In the northern winter, the pole is tilted away from the sun. We get less direct sunlight and fewer hours of sunlight than darkness. In between summer and winter, the days get shorter, and there must be some day when they are almost the same length. This is what the Earth looks like on an equinox. So next, let's agree on an important detail. How do we say the length of a day? What's the definition of daytime? Day is when it's light out, right? Because of the sun, not because of streetlights. And night is when it's dark. But what about the twilight times? In the summer, it might start being light outside before 5 a.m. Is it already daytime before the sun rises? Well, saying it like that sounds a little silly to me. So I'm going to suggest this simple definition. Day is the period when part of the sun is above the horizon. That will include sunrise and sunset. And that means that night will include those twilight times. Okay, let's take a look at the sunrise today, here at 21 degrees north latitude on September 22nd. Let's watch that again a little closer to get the exact time. Okay, so 6:20 a.m. is when the sun first peaks over the horizon. Let's write that down. And let's time warp right along until sunset. And zoom in a little closer there too. My clock here is in 24-hour time, so 1826 means 6:26 p.m. That gives us 12 hours and 6 minutes of daytime. That's close to equal parts, but not exactly. Thankfully, people have been making charts for years and years of the times for sunrise and sunset. If we take a look at the entry for Honolulu, here it is. Sunrise at 6:20, sunset at 6:26. So it looks like we've probably got the times right. Is it possible the actual equinox doesn't happen today? Let's go look up the actual definition. Remember, we only talked about the Latin meaning so far. The Webster Dictionary gives two definitions for equinox. First, either of the 2 points on the celestial sphere where the celestial equator intersects the ecliptic. Second, either of the 2 times each year when the sun crosses the equator and day and night are, everywhere on Earth, of approximately equal length. Now, both of those definitions talk about an equator. And both of those definitions are specific. The equinox is a point or a time, not a day. Definition 2 sounds a lot like what we've been looking for so far, when day and night are of approximately equal lengths. But definition 1 uses some unusual vocabulary. We've mentioned the word ecliptic in our previous video about the planets. That's the imaginary line that is the path of the sun, moon, and some planets across our night sky. The celestial sphere is a way to look at the coordinate system used to tell positions of things in the night sky, independent of where on Earth you are. The celestial North Pole is always directly above the Earth's North Pole, and the celestial South Pole always directly aligns with the Earth's South Pole. We can draw a celestial equator by taking the circle of Earth's equator and extending it out towards the stars. This is the light blue region in this drawing, extending out from the middle of Earth. Let's now have a look at this in our planetarium. Here's our view of the sun at noon today, the day of the September equinox. Let me turn on the lines of the celestial sphere. I'll turn them off except for the equator. Next, I'll also hide the atmosphere and the ground so we can see the sun clearly. I'll just draw a green line to show the horizon. Let's zoom up close to the sun and watch to see when it is centered on the equator. I'm moving us backwards in time from noon. There, that's pretty close. It looks like the true moment of the September equinox is about 3:20 a.m. Hawaiian time. Well then, if we're looking at the center of the sun to cross the celestial equator, what if we count our daytime from when the center of the sun crosses the horizon? Here we are at sunrise again. The sun's center appears only about 90 seconds after sunrise starts. That won't be enough to make up our 6 extra minutes of daylight, will it? But watch this. What if I hide the atmosphere again? Now wait, I didn't turn off the sun. It's just still below the horizon. How is that possible? That's the effect of something called refraction of light. Hold that word for a moment, we'll come right back to it. Now we can see that the sun truly crosses our horizon at 6:23 a.m. Refraction is when some material, like water, glass, or air, causes light to bend as it shines through it. The thicker the material, the more the light bends. So when we look through the atmosphere near the horizon, there is a lot more refraction than when we look higher in the sky. In the atmosphere, refraction can let us see objects that are actually slightly below the horizon, like buildings, ships, or the sun. You can use refraction to make light bend yourself, for example, when you place a straw or your finger into a basin of water. Similarly, at sunset, the atmospheric refraction lets us see the sun even after it should have already disappeared below the horizon. We can see the true sunset is at 6:23 p.m. And there's our 12 hours. But we could only watch it if Earth had no atmosphere, and that would be no fun. Does this all mean that there's not actually a time when we can see exactly 12 hours of day and night? Well, there actually is. Well, very close, but that day is not the equinox. Let's watch sunrise and sunset for a week to find out when they're closest to 12 hours apart. And there it is, on September 27th, 2020. If you're living on Oahu, sunrise and sunset will happen exactly 12 hours and 15 seconds apart. That sure is close enough for me. And there's a name for that day, too, the equilux. In this case, lux means light, so equilux means equal light. Thanks for joining us for today's presentation. Remember that Tuesday, September 2nd, 2020 is the equinox, but tell anyone who asks that the real special day is September 27th, when we actually have an equal day and night. Stay safe and join us again soon. Aloha and goodbye.